need. If you're on Mac or anything as such, you can go on downloads here, and the drop down, you'll find what you need. You can download it there, and then what you'll find is the specific IDE for Python that comes with Python. Now, IDE, don't worry too much about the acronym, but what it means is basically just environments. Now, if I was to open this IDE, now I've already done it myself, I will find something that is very similar to Notepad. I can just write right here, and as you can see, I've already written some things, and it's quite simple. So I can do 2 + 2, and now, thanks to this specific environment compared to the one like Notepad, I can actually press Enter, and it's going to send this code to my computer for it to run. It's run, it's done the sum of 2 and 2, and it's 4. Wonderful. This is very much 101, how to use Python, how to download it, what to do once you've got your environment. However, I'm going to be going through now our APIs, and I will reiterate, welcome to the Refinitiv developers community, because I'm showing you developers.refinitiv.com. Now, this is the website for you where you'll find all the documentation about all of our APIs, basically just everything. And I'm going to be talking to you through quite a lot of material, and I've saved this material somewhere here for you so that you can refer back to it later. You can find it in articles. So here in the developer portal, you have API documentation. I'm going to be talking about what that means exactly in a second. Articles, which I'm going to be showing you right now, among many other things. So developer tools, for example, which allows you to play with the APIs, play with the technology in order to find out how it works so that you can then put it into production. Use cases are very interesting. I think you might be most interested in artificial intelligence, for example. So if you just read more, you'll find a series of articles, a series of use cases specifically for these things. Last but not least, I think, is the Q&A. Now, Q&A is basically like Stack Overflow, for those of you who know, but specifically just for our technology, for our APIs. What Stack Overflow is basically just a Q&A. It's a series of questions that people have asked in the past and answers. And it's also a place where you can ask your own question. I would invite you to search for your question first. So here, for example, what is the data limit? I'm just making this up, right? But let's say, I'm looking for data limit for a specific technology within the London Stock Exchange, and you'll find that there are answers already in there. They go data limit for streaming for different APIs. Now, I may have gone too far already because I didn't explain what an API is. So let's have a look at the article I mentioned, through which I will go with you today. So I went on articles, by the way, at the top, then I went to see all articles, and I'm looking for this one, summary of common LSEG Refinitiv APIs. I speak about several APIs here, but today we're going to focus on just the Refinitiv data library for Python. And you can find all that I'm going to be talking about today in here at the top right, source code, because I'm going to be showing you quite a bit of code, and an article like this is great, right? And you actually have code within these articles, but I prefer to have it in the source code. If you click there, it will send you to a site called GitHub. For those of you who know, GitHub is basically a repository where you can find code, things such as notebooks that I'm going to be showing you now. Here it is. So if I was to click on here, Academy RDL session, now it says 001 because I'm going to be updating it, and I'm probably going to be writing some code today with you, and then I'm going to be uploading a new version right here. So you'll find the new one after today's call. And if you were to click on there, you'll find the notebook. What's the difference between notebook and just code? Notebook is quite nice because you have both text like this, you have links. So for example, here there's a link to just the Python page that I was showing you in a second, and you also have code cells. So if I go back here right there, this is a code cell. So in that cell, I have written code. In that cell, I did not write code. I just wrote some text with some links, for example. Now this is all quite cute, but this far you're not able to run this notebook. We within Refinitiv have created an application within our program called Workspace, where you can interact with notebooks such as IPYNB notebooks. Now, when I say IPYNB, that is the extension on the file in question. If it says IPYNB at the end, it's a notebook. If it says TXT at the end, that's just a text file that you can open with Notepad, for example. So here is the notebook in question, and you may want to upload that onto an environment where you can just play with it straight away instead of just copying and pasting everything time after time. To do that, you can use Workspace. Now, for those of you who don't have Workspace, don't worry, I'm going to go through everything today, but Workspace is, I don't know if you know Icon, it's just Icon 2.0. It's our main product. On here, you can find an interface for financial data of all kinds. So here on the left, I've got some information about the S&P 500. I've got some news scrolling at the bottom right on global financial news. And at the top right here, this is what I wanted to show you, is Codebook. Now, if I was to go on the search bar here at the top, if I was to write Codebook, it is an application that we have within our program. I've already opened it up because it takes a short while to spin up. Codebook is an environment within Workspace that is called JupyterLab. Now, some of you may know what JupyterLab is, and JupyterLab is an IDE. So when I was talking about this IDE here, this is a very simple IDE. It just says 2 + 2 = 4 and things as such, but I didn't have the text, I didn't have the notebooks that I was showing you in a second on GitHub. Here you do. I have an environment and a Amazon Web Service bucket where I have all of the files that I need. If the files start with __, I would strongly recommend not to write code in there. Now you can go in there and you can have a look at what's there. It's extremely interesting. As a matter of fact, I use it nearly every day because there are a lot of examples of how to use our APIs. However, they can be overwritten because we have new examples all the time. We have new APIs all the time, and we add examples, we add documentation and things as such in those places. So here where it says __, I don't tend to write new code. I just use it for reference. But here at the bottom, you see that I have the notebook that I was mentioning, the Academy RDL session 001. How did I put it there? Well, it's quite simple. At the top here of the navigational panel, I know it's quite small, by the way, but I'm going to get something a bit larger in a second. At the top here, top left, it says upload file. If I was to click on there, I can then navigate to where I have my file. So I can show you this here, for example. There we go. So here I have my file right there, 001, and I wanted to show you doing it for 002. Well, actually, I'll show you on my own environment. So here I have JupyterLab within Codebook, the application within Workspace. I prefer personally having just my own environment. So I have JupyterLab on my PC, and it looks exactly the same. Now I'm showing you this on my own PC on purpose because I really want to emphasize the fact that it's the same as what it is on Codebook. I was able to zoom in a bit more here, but this is the notebook I was mentioning before. Now it says 002 at the end because I've updated it a tiny bit, and at the end of today's session, I'll upload it to GitHub where you'll find it in the article I showed you at the start. Conveniently, I've already spoken about Python. I've already spoken about IDEs. IDEs are the environments, by the way, such as a notebook, such as the Python IDE called idle, by the way, for those of you who want to know. But I wanted to talk about objects. Now, a computer coding language is nothing other than basically just a grammar that you need to follow in order for your computer to understand you. There's a very good reason we call it a language. If I was speaking to a Frenchman who doesn't speak English and speak English to them, they wouldn't understand because that whole grammar, that whole structure is not there for them to understand, and vice versa. So I need to have a language that the computer is going to understand. And thankfully, the computer speaks quite a few languages, and we can have layers of languages. So I can write Python, for example, which will be converted into another language, which then will be converted into whatever the computer can understand. There are several languages out there. You can have some like Python that are quite, it's called high level, and there are others such as R. R is extremely similar to Python. I would really encourage everyone to try and have a go at R. It's very good for mathematics, statistics, computing, mathematical modeling, things as such. And yeah, it's extremely similar to Python. If you code Python, you'll be able to just pick up R quite quickly. And those are very high level languages. What I mean by that is that it's quite far from the chip. It's quite far from quote unquote the silicon. It's quite far from the computer language. I think it's called assembler at the very bottom. You have others that are a bit closer to the machine, closer to the chip, and they tend to be a bit harder to code in than things such as Python, because they would ask you, for example, to manage your memory. That's a big deal, by the way, something that you do not have to do with Python. They range, you can go from C to C++ to Java. There's loads of such languages, but within Python, there is something that's quite interesting, and that's the fact that you do not have to tell your computer where the memory is. So here, for example, I could create an object. What I mean by that is that I am assigning the object A the integer 3. So I'm saying A now is 3. When I'm doing this, I do not have to tell the computer where this information is. With a function such as hex ID, I can find out exactly where that object is. But when I said A equals 3, there's quite a lot to unwrap in there already, because there are several types in Python. There's several types of objects in all computing languages. So here 3 is an integer. You can find out the type of any object with the function type, literally. So here what I've done is I've written type open bracket the object in question. So here is a close bracket, and I've got the object in question, and this says int. Int is for integer. There are several objects such as float, for example. Floats have decimal places. You can be, if you write 1.0, it will record 1 as a float, so you'll have your decimal places. You can have other things, just there you go, 43.9, why not? And that's also a float. You can have lists, so you can have several objects within an object. The object is a list. So here I've got several integers within my list, and I have assigned that list to the object D. So here D is a list, as you can tell, with the type. You can also have strings, for example. So here the string E is going to be hello world. So if I was to write E here, there you go, hello world. So that's a string. What a string is basically just an integer. It's not a float. It just has characters that I can refer to later on. The reason why I wanted to speak about objects is because later on we're going to talk about data frames. Yes, that's right. So within Python, such as other languages, you'll have functions. There are some native functions. So for example, here the plus sign is seen as the sum function. So if I have a plus b is going to give me 4, just like I showed you before within the Python idle IDE. The star stands for multiplication. I'm not going to go through all of them, right? But double star means to the power of. You also can change the type of an object with native functions such as int. So int is a function whereby I'm going to change the float c into an integer. So I've lost the decimal point. The decimal point was 9, by the way. It was 43.9. I've lost that 0.9. Note, however, that this is a function. I did not allocate memory for what has just happened, which means that I've lost all memory of what's just happened. This is still useful, so I may want to do something to have a look myself as a human being what happened, right? So the .9 went away. I'd like to see that. I'd like to test that. That's what I've done that for, but I did not save that in memory. So if I was to have a look at C is still 43.9. If I want to allocate the integer C, I'll have to do something such as C equal. You see, I'm allocating the object int C within C. So I'm just going to remove all of that for now. Oh, there you go. I've done it right here. The last one I want to talk about before we get into some more tricky things is print. So I'm just going to print here print the type of what I'm looking for here, B, and also you can do some addition with strings. So if you were to do an addition with strings, for example, here, I could, I think my keyboard changed to French layout. I could have a string. So for example, hello, and then do a plus. However, if I was to do something like that, it's not going to understand. And the reason for this is the types. That's the reason why I was talking about types before. You need to be careful of the types of the objects that you're using here. If you were to use the plus native function within Python with strings, you have to use strings with them. So here I've got hello and then world. And that's what I'm doing right here. E, if you remember, is an object that is a string, and I'm doing plus, comma, space, hello. And it prints it right there. Now, these functions I spoke about, such as print, type, int, they are all functions that are native within Python so that you don't have to create them yourself, but you can create functions yourself. You can create them with this nomenclature, this grammar. You can def space, the name of your new function, and then the parameters within your function. So here I've got 2 parameters, x and y, and my function is just going to do x times y, and it's going to return that product. And here I am defining that function. Here I am using this function. So you see how I am defining and then using it. I am specifying variables for the parameters. So here's variable 5 for parameter x, 6 for y is going to give me the product of both, and that's what it's done right here. 5 times 6, 30. Perfect. The last thing I wanted to talk about in terms of functions is also f-strings. Now, f-strings is a bit different from everything else because this far for the functions we had, they were either mathematical functions, just times or plus, or they were functions you have at the start, and then you open your brackets, and within your brackets you have the variables you need. Yes, F strings are interesting because you can put F in front of a string, and then within curly brackets put the object that you want within your string. Now, remember what I said last time, it needs to be the correct object. If it's the wrong type of object, you may end up with an error like we did before when I tried to add a string with an integer. But here, that's what I've done. So type A happens to return a string, so I can put that in there, and I have some interesting message that I can show on the screen. All right. Now, you don't have to create all your own functions, thankfully, because otherwise you do nothing but create your own functions and never do the work that you're there to do. The one that is most often used, especially in data science and data management, is pandas. Pandas is a bit like Excel. It's a data frame management library, and here you can install libraries with the command pip install. Now, within Jupyter you should be able to do this. So you just type pip install within a coding cell and run it, and it should be fine. If it doesn't work, you may need to have an exclamation mark at the start. The reason for that exclamation mark is just to let Jupyter know that you're actually bypassing Jupyter itself. You're just going straight directly to Python, to where it needs to be run, and it's going to pip install the library that you want. So here I'm speaking about pandas, but there are very many libraries. NumPy is another one that you may want to know about. But here, this is one way to pip install libraries. One note here is that if you were to use Codebook, which looks exactly the same as the Jupyter Lab that I was showing you, you can't pip install on Codebook. However, there are so very many libraries, I haven't found the need to pip install anything. So if you were to go here, help, Codebook libraries and extension, you'll find all the libraries, all the extensions. There you go, there's quite a few. So that was just a side note. Here, once you've pip installed pandas, you've pip installed the library that you're going to be using, which is basically just a set of functions that may be useful to you. I can then import pandas into my code. So that's what I'm doing right here. And then I'm using one of the functions within pandas. So pandas is a library, and within pandas, there are normally two things: classes or functions. Class is basically just a set of functions. You can speak about them interchangeably. I won't do that because I don't want to make things a bit incorrect. But that's in effect, it's the same thing. If you have a look at the place where I am running my code right now, I have put in a Excel data frame. It says .csv because it's comma separated values. So if I was to open this, it's very, very simple. It's a data frame of 1, 20, 30. I couldn't make it any simpler. You may want to import data from an Excel sheet. If you were to create your own functions within Python to do that, it may take you a very long while. Thankfully, Pandas has done that for us with the function read CSV. Now, CSV was the extension that I showed you at the end, data.csv, and I have put that CSV file in the same place where I'm running my notebook. This is very important. If you do not do this, if you do not put your Excel sheet where you're running your code, you're going to need to put the absolute path. So the absolute path normally starts with C. You'd have C : / I don't know, user, and then all the path all the way to your file. Note also that I've put 2 /. There shouldn't be 2 normally. Normally there's only 1. The reason why I need 2 is because a / within a string in Python means something very specific. And in order to tell Python that this is actually a / and it's not a function, I need to put 2 of them in there. So that's just FYI for you to know. All right, so that was pandas. You do not need to import from CSVs if you do not want to. Within pandas, you can create your own data frame. So here I'm using the pandas library and the data frame function within that library to create my own data frame. And I'm going to assign this data frame to the object that I'm going to be calling df1. So here, df1 is the object that I'm creating with the function data frame within the library pandas. The library pandas has multiple parameters, but I'm only going to be using one here, the parameter data. And within that parameter data, I'm going to be entering data. Here I'm using a dictionary. Don't worry too much about what a dictionary is, but basically it's information that is put within curly brackets. I have the string colon1, which is going to be the name of my column, the list of integers, which is going to be my data, and I can do this for several columns. Once I have assigned this data frame to the object df1, I can have a look at it, and here I can do so literally just by writing df1, and then it runs it. I can show you this right here. So if I was to write df1, and that's something that's really nice about Jupyter Lab as well. This is something that is not native to, let's say, IDE, the idle, the native Python IDE. So if I was to do this, I can see df1. Within any other environment, you may need to have another function simply just to show the data frame. But within Jupyter Lab and Codebook, that's native. All right, so here I have my object df1, and I can have a look at the object simply just by running it in this cell. By the way, I've been creating cells, deleting cells, moving cells around this whole time, and I'd like to show you very quickly how to do that. I normally put my cursor where that little number is. This is the number of the cell. This is the 51st cell that I am running within this notebook, because I was doing some testing before showing it to you today. And if I was to click on that number and then click on D twice, that's going to delete that cell. In order to create a cell, I can just go to the left of any cell. So this is called a markdown cell, by the way. It's one that doesn't have any code in it, it's just text. If I was to go to the left of it, press A, it's going to create a cell above. You can press B to create a cell below as well. I just wanted to show you that very quickly. Okay. The reason why you may want to use a library such as pandas to get your data in your data frames is, instead of just having just a list, why not just a list, right? Or a list of lists. That's perfectly fine, by the way. You may want to do that. It may be faster to do some computation in that way. But pandas comes with so very many functions, even within its own data frames. So here, df2 is a data frame. And it's a pandas data frame. Within that pandas data frame, there isn't just data, such as what I'm showing you right here, but there are embedded functions you can use. So here, for example, I'm using the function sum. And what it's doing is that it's making a sum of each column. So with column 1, the sum is 11, column 2, sum is 15. It's also giving you the data types within that data frame, which is very useful, because later on you may have the wrong data types. You may end up with errors. Just doing this right here shows you the data types, and that's quite good. There's another one called .plot. I wanted to show you this because it's quite a simple and quick way for you to plot anything. So this uses another library called matplotlib. You do not need to install it. You do not need to import it. You do not need to pip install it, because it is within pandas. If you use it within the pandas functions. So here I'm using a df2 pandas data frame, and the .plot function is embedded within that object, and it shows you some graphs. All right. That was all Python. It did take a while. I'm sorry for those of you who already knew Python and how to code, but I really wanted to go through this because it's important. You may not have all the data that you want. You may not have the Excel sheets full of all the data that you want. Therefore, you may want to use a library that allows you access to the data frames that you want. And that is exactly what the Refinitiv Data Library for Python is. It's the London Stock Exchange's API for financial data. Now, API stands for Application Programming Interface. Don't worry too much about that acronym. All it means is that you have a direct access to data frames that you have a license for. Now, obviously, you need to pay for a license for access to this data. But once you do, you can use the Refinitiv .data library. Now you can pip install this outside of Codebook with pip install Refinitiv-data. And once you've done this, you can import it within your environment. And I've called it DL. Now you see here what I've done is I've imported my library, and I've said as DL. The reason I've done this is because I don't want to have to write Refinitiv.data every single time. I just have to write DL, and it's just as if I wrote Refinitiv.data. And here you can see I'm just showing you what the version of my Refinitiv data library is. It's 1.2. That's also one of the reasons I wanted to show you the F string. I think that's really interesting. And here you can see I've done ..__version _ at the end. That is extremely useful. If you have errors coming up in your code, sometimes it may be because you have a library that's out of date, or maybe you need to go back to a different version. In order to figure these things out, this function here works most of the time. I say most of the time because it depends on who wrote the library. Some people write a library and don't put that function in there, and then you're gonna have to find another way to find the version that you've got on your machine. But FYI, that's how most people that write libraries allow you access to finding out what version it is. All right, so when I showed you the article at the start, this one, summary of common LSEG Refinitiv APIs. I speak about our APIs right there. Now, it's a good article for you to have a read, and I speak about it within the notebook, so you don't have to go to the article. Within the notebook, I specifically look into Python and Refinitiv Data Library and not other APIs. The Refinitiv Data API can be used with two sessions, one called platform, one called desktop. We're going to focus on desktop, but just for you to know, the platform session allows you access to the data frames just at any point, anywhere, anytime, even if you are not in front of your machine. So that's what's interesting about it, is that it's made for machines. For example, let's say that overnight, when you're not in front of your PC, you want code to run to fetch data. That's what platform sessions are made for. However, we are going to go more for what we call the desktop session, for which you need a desktop app running. Now, you do not need to specifically have the workspace desktop app. You can have the icon desktop app running. That's perfectly fine. That's the older version of workspace, the one I showed you just in a second. It's this right here. So this is the desktop application that I have installed on my machine. And if you want to do it yourself, if you want to install it, it's all the links that you need for installation and things like that are in this notebook that you can find in GitHub where I showed you. Once you have workspace on your machine, I'm gonna refer to workspace and not icon because workspace is a new version. You can have access to our data. So, and here, by the way, I speak about codebook. I speak about all of these things so that you can go back to this later on and work on all that. I've just realized I didn't actually, did I show you how to download? I don't think I did. When you're on GitHub, you can download notebooks directly. You don't need to copy and paste anything. So here you can press on code. I've gone back to GitHub, by the way, which I found here in this article. If you were to type this on Google, by the way, it will come up. And then top right is the link to GitHub, to the repository on GitHub. So here I can click on code, download zip. It's going to download a zip file. There it is. I've already got it on my PC. Here it is. And you can extract all. So that's going to extract everything that's in this zip file. And once you've done this, you can go in there. Here is the notebook in question. Now, once you have this notebook, you can go on codebook and upload that one in question. I forgot to show you that at the start. Once you have workspace, the workspace desktop app running on your PC, you are going to have to authenticate yourself to the Refinitiv services in order for us to know which license you have and what data access you have. In order to do this, you will need to authenticate yourself with what we call a configuration file. You can find all the information about the configuration file in this notebook yet again, and there is a link in there to, there you go. There. It says you can find the configuration file, but it says more about the configuration file there. It was here. So if I was to click in there, I can go in configuration, refinitiv-data.config.json. This is the file that you need. You need to take this file and fill it in yourselves. So we are going to focus on the desktop session, as I said, and you can find it here, desktop workspace. So once I have the workspace desktop app running on my PC, remember again, you can have an icon, that's perfectly fine. Once you have that desktop app running on your PC, you can use the desktop session by putting your app key right here. In order to find your app key, you can go on workspace. And again, all of this is written in the article for you to have a look at later if you forget. If you were to go on workspace, I'm just going to go on the new tab and I can type app key. I can't show it to you, unfortunately, because otherwise you'll see my app key, but you can find your app keys in there. There are different app keys you can create. And again, all the specificities about these things can be found in this notebook. There's links as well to very good articles that explain everything about that. And you'll have your JSON file that looks exactly like what I've showed you here, right there, that you can copy and paste within your own PC and refer to in order to have your app key and authenticate yourself to the Refinitiv services. And this is what we're doing right here. So the data library, Python library that I've imported at the top of my code, I'm using it right here. And I'm saying that I'm using the function open session within that library. Within that open session function, what I can do is I can authenticate myself to the Refinitiv Data services, and I can then start requesting for data. There are several parameters within this function. Name, so here I am again specifically looking at desktop.workspace because we're looking at desktop sessions. I have written here, there you go, rdp.platform. That's the one you can use if you want to use platform. By the way, you can also create your own sessions. So within your JSON file, here you can say, you see it says the platform RDP, you can create your own. You can create, at the end, you can write comma and then something else, John Doe, and that can be your John Doe session. Why would you like to do this? Well, because maybe you have more than one app key and you'd like to test one app key compared to the other, and you'd like to do that quickly. That's perfectly fine. And you can do this here by changing the name. I'm also telling my computer where my configuration file is. So I told you can go in there, copy and paste it, and you can then paste it on your PC somewhere. And here what I'm doing is I am telling my PC where I have pasted this information, where this information is, and it's within this JSON file in this location on my PC. All right, once I've done this, I've opened my session, I've authenticated myself to the services, and therefore I can start asking for data. And it's actually quite simple. This was the hardest bit, authenticating yourself. Now that you've done this, you have access to the data library functions to get data. So the first one I'd like to talk about today is get_data, which is the simplest. Here I'm looking at data for LSEG and Vodafone. I'm looking for revenue data, and here is my data. So I've assigned the object data frame, DF3, which is a data frame, to the data returned by this function. And here it is. So I have my instrument, I have the date for which I want my information, which is the revenue for this company, and here is the information, so the revenue. And I've got it for LSEG and for, by the way, LSEG stands for London Stock Exchange Group, and Vodafone. Now that is quite a good one. However, not all fields are accepted within the get data function. The get history one is a bit better in that regard. You can put different types of fields in there, and normally it will work. So here, for example, I am using capital fields. I call them capital fields. They are real-time fields. If they're all capital letters and there's no TR dot at the front of it or anything as such, they're normally real-time fields. So here I'm looking for bid, I'm looking for ask, I'm looking for TR revenue. Now I know I said real-time fields, but we do still collect them and we keep them. So you can refer to them in the get history function. It's just that they're different in terms of the types that they're saved in the backend, but that's not something to worry about as a developer using the data library. So here I'm using the get history function within the data library, Python library, and I have my universe, and I've written lseg.l as the symbol for the one that I want, the list of fields that I want, the interval, the start and end date. However, I've spoken a great deal about variables. I've spoken a great deal about fields. I've even said I've put in LSEG in there, but what is LSEG? Like, how do you know that LSEG.L is the correct symbol here for what you're looking for? There are several ways to find these things. However, first I'd like to speak about the variables within the functions. So here, I have used the get history function, but I knew, because I've used it so often, that within that function there is parameters, universe, fields, interval, start, end, and there's others as well. How can you find the ones that you want and the ones that you need? There's two ways to do it. The way that you can go about is on the developers portal. So if I was to go there, developers.refinitiv.com. In there, you'll find when it doesn't crash. If you were to go on their APIs, you'll find when it doesn't crash again. Under APIs, you'll find all the documentation you need for all the APIs and the functions that we are using. And it talks about all of this. However, I have another way of doing things that I prefer. I normally use the doc strings, and you can find doc strings right here. So if you do help with any function, you can do so like this. So if you do help, which is a native function within Python, you can use the data library and the function that you want, on which you can have the parameters that you want. So here I can see that I have several parameters such as universe, fields, interval, and I know which ones I can use because they're all in there. Now, doc strings are not obligatory with every library within Python. However, we've chosen to go for them because, as you can see, it's quite useful. And we have documentation about each one of them. So here, for example, interval, there are several intervals you can use. You can go for tick, you can go for minutes, you can go for 5 minutes, all the way to 1 year. And 1 year is 1 capital Y. If you do 1 and then a small y, that won't work. Okay, so with this in mind, how do you know? So now you may know what interval is, but you may not know what this is. Now, this is what we call a RIC. This is a Refinitiv identifier code. So if I was to scroll down a bit more, because I speak about this, there you go. Where can I figure out the fields and the Refinitiv identifier code that I need? You can find them very simply within just workspace. So here, if I was to type Vodafone, there you go. Vodafone comes up at the top. And at the top left, I can see the RIC, the Refinitiv identifier code that I need, VOD.L. And that's the one I can use within my function. Whilst that's perfectly fine, how can I now find the fields that I need? I spoke about the types of fields, you've got real-time fields, you've got TR fields, which are normally historical. Where can you find all this? Well, you can find all this within the data item browser. And again, the data item browser can be found in Workspace. Here, I really can't emphasize how powerful that tool is. I use it every day, quite literally, because I don't know the name of every single field that's possible for each instrument that you can find within our data frames. I normally use 3 things. I use that little filter at the top left, normally specifically to have a look at the type of data that I want. So I told you before that I could be doing some mathematical function or something, and then there are just incorrect types. I could be doing something with a float, and then the other thing is a string. It could be a date even. In order to make sure I don't make that kind of mistake, I go here in the filter, and then in the data type, I go for the one that I'm looking for. There are other filters, I just hardly ever use them, but go for it if that's of interest to you. So here in the content classification, you've got some interesting stuff, reference and identifiers, real-time, price and volume, right? That's interesting stuff for you. Here at the top, there's normally it should be like this. There you go. It should be empty. The reason why it was full was because I was looking at a equity, just before an equity instrument, specifically Vodafone. So here, if I was to type Vodafone, I could go for something else, right? Microsoft, Apple, LSEG, any that you're interested in. All right, so now I'm specifically looking at a RIC, Vodafone. I've told you that I can look for a specific data type. However, what's more interesting for me is this right here. I can filter. The first filter was just removed whatever you didn't want. But here I can toggle. So here I can go, if I only want real time, I can remove everything and keep only real time at the top right, real time. If I only want time series, I can do it this way. What's most interesting here within this specific cog filter, as I call it, is blank values. I can remove the blank values. That is extremely important because otherwise you can end up with an enormous amount of, there you go, an enormous amount of fields that you're not interested in, for which there is no data. There's no data for several reasons. For example, there may be a country that requires a certain, I don't know, figure to be shown within balance sheets, but it doesn't show up in any other country. So for any other country, that field will exist, but it will be empty. That's just an example. All right, that's what it is. Now, you may be wondering, why did I have to write the RIC here? Why did I have to write the company's name there? Well, because you may not only be interested in equities, you may be interested in anything else. Let's say, I don't know, options. I think if I put, no, that's not going to be one. Oh, let's go for a bond. There you go. So here are actually, that's a spot. There you go, a spot rate. I mean, literally any instrument that you can think of, you'll find it within the data item browser. So you have spot rates here, you can have forwards, you can have just any instrument that you're interested in, and you'll find the fields that are specific to that instrument. When you think about it, that's a bit obvious really, because what this means is that I'm not going to have a field such as expiry date for an equity, because that doesn't fit, it doesn't make sense. You might have an expiry date for a bond, but not for an equity. And so that's what you can find here. By the way, every time you type something in there and you look for something, so I'm getting now to the third piece that I use most within the data item browser, which is just the search bar. So here, let's say I'm using for, I don't know, a spot I don't even know if that's, I have no idea if that is a field for that instrument, but I can find that out by typing spots within that search bar. And lo and behold, it is. However, you can see that they're all empty. So here I can remove the blanks and then be interested in something else. So I feel right. Rate. Again, I don't even know if that is a field for that instrument, but it will come up. And at the bottom, let's go back to an equity. Let's go for LSEG. If I go for revenue, let's say, once it wakes up, I'll click on one and you'll see that at the bottom right, you will find the field in question. The reason why it's there is so that it's just much simpler for you to copy and paste from. There you go. So here, if I was to click on this one, let's say that's the one I'm interested in. At the bottom right, it says tr.turnover. I can copy it just by clicking on there. Then I can go back to my code and I can write that field right there. So if I was to do this, boom, tr.revenue, turnover. So here, if I was to run this code, this is going to assign the data that I'm going to collect back from the API to my Python object that I've called df4, and it's going to return it to me. And as you can tell, just by looking at it, it is a pandas data frame. What that means is that you have all of the pandas functions, such as the sum function that I showed you in a second, right there for you. Yes, I mean, that's the gist of things. I showed you the data item browser. Again, everything is written within this notebook for you to have a look at afterwards if you want to refer back to it. Now that's one way for you to find the RICs, find the Refinitiv identifier codes. But let's say you already have some. You have some tickers, some symbol, some ISINs that you are interested in, and you just like to use the functions that Refinitiv give you in order to find the data that you want for those ISINs. Well, you can do this with the symbol conversion. This is a function within the data library. So here I'm just referring to that function by writing dl.content.symbol_conversion.definition. So it's a bit hidden, right? You have to go dot something quite a few times. However, it's in there. And here what I'm doing is I am collecting the data that I want specifically for this RIC. And I'm looking at converting a symbol from one to the other. So here I've used RICs for Microsoft and Apple, and I'm saying that I'm going from these symbols and I'm going to a different symbol type. So here, let's say I'm looking for an ISIN. I spoke about going from an ISIN to a RIC. Here I'm just doing the opposite. So I started with RICs and I'm going to ISINs. And as you can see here, once you have defined what you are looking for, and that's what the definition is there for, I can then get data, and that's what this function is there for. As a matter of fact, you know what? I'm going to show you this. Yes, yeah, I'm going to do that. Copy, paste. Yeah. So this is only just a definition. So I can assign this to an object. This is my definition of what it is that I am looking for. Once I have my definition, I can then get data. I can do within this object that I have created and I have assigned to defin, define. I can then do dot get. There you go, get data. That is going to take that definition that I've created, send it to the LSEG services, the London Stock Exchange services, and get you the data that you're after. So here, this is going to be my defined df. Yeah, like that. This is going to be my data frame. However, you know what? I'm not even going to call it df because it is not a data frame. That's exactly what I'm getting to right now. I want you to know this. It is a response. So I have sent this request to LSEG and it's returned with a response. It is not a data frame. So if I was to do this, I can have a look at my response. And that's what it is. It's a very long message. I think it's JSON. And it has all the information you need in there. However, what we've done, instead of giving you the raw API response, we have created packages within this object for you to collect the pandas data frame that you're after. So if you were to do .data within that response, it's going to give you just the data within that response. However, again, it's raw data. The reason why we've done this is because there are many developers that want data in different formats, right? However, we're fully aware that mostly data scientists, right, they want everything in data frames, need data frames they can then move and arrange, and that's what we've done this for, data.df. And you can find the data that you want in there. Note that I did not have to do this for the function get history and get data. So this is get history, and I did not have to do the get data and the get df and all of that. The reason for this is because get history is very specifically for you. It's very specifically for data analysts, maybe quants that want to do some backpropagation analysis, some trading simulations, things as such. That's perfectly fine. However, when you end up with things such as symbol conversion, things as such, it's more of a raw API call, and you send a request to the API endpoint, and it returns with the information that you want in whichever format you want. So you can be just like this, get data, some raw JSON data, or you can go all the way to a pandas data frame, like I've done it right there. I showed you just now how you can find your RIC. Maybe you have a list of ISINs, you have a list of symbols, and you can just convert them to RICs. Why would you want to do this? Well, because then once you have a RIC, you can use the get data function. You can use the get history function, and every other function you'll find within the Refinitiv LSEG APIs. I showed you how you could find the RIC within Workspace simply just by typing within the search bar. However, and I really wanted to show you this because it's outrageously powerful. Let's say I am looking for a great deal of RICs, not just one, but a whole universe of RICs. And in order to find them, it's very difficult. This is an example of me. I'm writing an article right now, looking for options that are at the money for specific instruments. And I want specific options. So I want options that are, there you go, not weekly. I want only monthly options. I want options that are specifically traded within the SDX and nowhere else. You can do this with the search API. The search API is immensely powerful. It allows you to basically recreate yourself as if you were to take hours to go in there, type in that search bar, and type the things that you're looking for. Option, Apple, and then it comes up with all the options, and then you're looking for the one that's at the money. It's going to take you a very long time. This is what it does right there. I'm not going to go through the entire function because it's quite long, and there is a really good article right there. There's a link for it here. I think if I click on it there, for some reason it's breaking because of Teams at the moment, but it's right there for you to have a look at. And you can send a query. Here I've gone for the Stocks 50, so I'm looking for options on that Stocks 50 index, and I'm selecting a set of fields that I am after. So here is giving me document title, RIC, strike price, expiry date, and things as such. And I have a filter. So as I said, I don't want weekly ones. I only want monthly options. I only want ones that are traded within the Eurex, blah, blah, blah. All these filters are right there. And I also want some that expire within a specific date range. And that's what it is right here. Greater than, lower than. I specifically made quite a complex call here because I wanted to show you all of these little ways to filter down your search with this LT, which means lower than, GE, which means greater or equal to, EQ, which means equal. I mean, it's pretty much all in there, and I've done it on purpose so that you can go in there, copy and paste, and do what it is you're after. As you can see here, I've done that whole ROM roll again, .data.df, so that I could find the pandas data frame I was after, and here it is. Here I have all of the RICs that fit my search. Now, note that I wrote top 100, so I'm only looking for the top 100 results of my search. I could go quite a lot further. I think 20,000, if I remember correctly, is the max. And if it comes back to me with less or fewer than 100 rows, then I know I have the entire universe. There is none left, right? Here it says 100 rows, so for all I know, there is more. There could be 101, there could be 10,000, I don't know. So that's the one way for you to look at this. You can put this in the loop and then find the entire universe of what it is you're looking for. Once you have something like this, then the world's your oyster. You can do whatever you want. Here, I was looking at doing some implied volatility stuff. So what I did is I looked for the current price of the underlying, which is about a bit over 4,000, and I used that strike in order to find the at the money option within the entire list that I was looking for. So here you see I'm finding the option that is closest to the strike price, but is at the money, so it's just above it, 4,325, and the price was 4,321, so we're quite close. And once I have this, I can then look for the price for my option. So this piece of code here is there for you to find the price for your at the money option for any index that you're interested in. And you can go a lot further, especially with that search call I spoke about. Last but not least, because we're pretty much finishing right now, I wanted to show you how to make some pretty graphs, because that's always quite good. You can copy paste them, you can import them and put them into your PowerPoints and things as such. And here is one. Now I showed you one before that was quite static, for which we used matplotlib from pandas, but here I'm using plotly. I'm importing plotly right there, and I'm using it right here just to have a look at the prices that I was talking about. We do have 4 minutes left, so I just really wanted to show you something, which was the place. And again, these links are within the notebook right here. So if you want to go back to all of this and find all the links, they are right there. But if I was to go there, one of the links that will show up the most often is this one. This is a link to all of the examples that I showed you within Codebook. Now, so you don't need to have Codebook in order to find these examples and in order to use them. You can go right there, github.com, Refinitiv API samples, example.datalibrary.python. And in there, you have the examples, and I go in there pretty much every day. And in here, you have examples of search, which I've shown you just now. That was just an example for which I found a derivative, an option, and I could then find information for it. But there's a lot more. There was conversion in the symbology. Symbology is where I found examples that I showed you about conversion from an ISIN to a RIC, and there's quite a lot more. So here you can find some news, for example, if you're interested in news data. The examples for how to use our APIs for fetching news data is right there. And one that I wanted to talk about was Screener, which is not there. It might be within Access. So when I spoke about, there you go, you get data, get history, there are other options, and they are quite low down, quote unquote low down. The ones that are just fetch data and you retrieve data, and that's all it does. There's nothing more to it. Those are the access layer functions. You don't really need to know the difference between the two, right? Because the examples will show everything quite simply. But there are two layers. There's the access layer and the content layer. The content layer is more user-friendly. The access layer tends to be a bit less user-friendly. To be very honest, once you see the examples, I find them just as friendly as each other. But in there, I think you'll find Screener. There you go, screens. Screener is another way to create your environment of RICs. I really wanted to show you this because quite a lot of people that are interested in ESG environments, ESG companies and ESG data, they tend to have an easier time finding the set of environments of RICs that they're looking for. Let's say you're looking for, I don't know, all the companies in the US that have an ESG rating higher than 3. I'm making this up, right? Because I don't really know what ESG ratings there are usually, but they tend to have an easier time with screeners. I knew I didn't have the time to go through this today with you, but I wanted to show you where you could find that. And it's right there. It's within the access screeners. And yeah, in there, again, there's functions similar to the ones we spoke about before, and you can find it all in there, and it explains how to get all that. All right. I want to apologize because I wanted to speak about quite an awful lot more. I wanted to show you a backtesting example, but I knew that an hour was going to be a bit tight. If you are interested in things as such, by all means, do go in the articles right there. I mean, there's so very many. You can go through them, and you'll find use cases that I'm sure will cover quite a few use cases that you may be interested in.